Hello everyone, we continue our work with SQL fundamentals, and in this module we have performance. The main topics of performance are indexing, query performance, and concurrency. But the main topic is indexing, and this is what we need to start with it. Now, if you think about indexing, imagine you have a dictionary, and in that dictionary you have no index. And now in the dictionary you are looking for word door. How do you find on which page is it available? In that case, you might start with a sequential scan for each page in your dictionary till you reach to the word which is door. But if you have an index, and the index can point you directly to page number 200, and in that page you start to have all the words start with character D, then it will be easier maybe in another 2 pages to access to word door and find the meaning for it. So this is exactly what you need to have in your database. Of course, there are some other scenarios when it's even better not to use index, but usually it's a good idea to have an index which is going to point the location of data you are looking for, and from there you can access to your data. That is going to help the query to improve the performance and retrieve back the information in a less time. Now, when it comes to database, the index, what is going to refer to is going to refer to tables rows if the table is organized. Because when you compare your table with the dictionary, the data in dictionary is saved on pages, while in table, this is where we needed to save the data. So if the table data is being organized, then it will be easy to create an index, and that index is going to point to a specific row on that table, and from there maybe in another 3 or 4 rows I can find the information which I look for. In general, with indexing we have clustered index, non-clustered index, and finally we have a part which is distribution and statistics. And of course there's a demonstration to see how to perform index, but the demonstration we will save it to the last. By the end of this course we have one big practice lab. In that lab we will create everything from scratch. Create schema tables, create data tables, add attributes to the tables, then we insert data, we create keys, create relationship between tables, and also we are going to add the work which we are going to learn in this module and the next one. So by the end of the course, everything you have it in these theories, you will be able to implement it on the database directly. Now with the first type of indexing, the clustered index, and with this one you can compare it directly to a dictionary. So the characteristic of a cluster index on a columns, a table to be stored with rows logically organized by that column's value, and one clustered index per table. You cannot add more. To be able to use a clustered index, you need to organize and order your table according to a specific column. With non-clustered, the main idea of this one, it is separate structures with pointers back to the location of data, so that the indexes in this case is not going to be saved as a clustered index on the same table. Here you have a separate structure. That structure you have pointers. Pointers are going to point your main table to the desired rows or item, and conceptually similar to a subject index printed at the back of the book. Now with this one, instead of have one index being saved in the table, this one, the index is going to be saved in a different structure, and because of that you will be able now to have multiple non-clustered indexes, but you might have a side effect. First, you need to have more storage to be able to save the data on this additional structure, and in addition to that, it might add the processing time when data is updated, because according to the update of the data on the main table, you might need to update also the structure where you keep your index. So by aid of cluster index and non-cluster index, just keep in your mind the following. With index, you can have only one cluster index per table, and the index itself is going to be saved in the table itself. With non-cluster, you can have multiple clustered indexed, but you need to have an additional structure, and in that structure you are going to save the data relating to the index. With the cluster index, if you update the data, you don't need to modify or do an extra work for the cluster index, while in non-clustered, you will need now to do more work because the data need to be updated. So the additional structure who has the index will know exactly if there's any shift in the value of pointers to be updated, and by this the index will maintain its validity to access to the right row or structure in the main table and gain the right information. Now, another one when we talk about index, which is distribution statistics. With this one, describe distribution and the uniqueness or selectivity of data. By default, created and updated automatically, so you don't need to do an extra work if you want to follow the default configuration. It is used by the query optimizer to estimate the selectivity of data, including the size of the result. Large variance between estimated and actual values might indicate a problem with the estimates and may be addressed through updating statistics. The main idea here, the system is going to predict where the data is going to be located and retrieve back a selective data from that part to answer the request of the query. But when you have now a lot of data in your database, then expect for this technique not to work as being expected, and that is going to slow the performance of your database. So that's why you might find yourself need to use the index. Whatever we will do in this course, we just create now a small database with all the tables. So none of these methods which we need to follow are really going to impact the performance. Here is going to run either we use index or we use non-cluster index because we have a small database. But when we have a large database, then definitely we need to use one type of index. We have finished the index definition, and later in the major practice lab of this course, we will see how we can implement it. Thanks for watching.